Good morning, children. How are you all doing? I hope everyone is staying safe and fine at home, and I'm very happy to meet you all back with another new lesson in science. Before that, we all know we are all using the sanitizers whenever we are going outside to kill the germs in our hands. This alcohol based sanitizer is very effective in killing the germs. One important thing we have to follow after using this sanitizer is we have to wash our hands before we handle any fire or any cooking work inside the kitchen, because all these alcohol sanitizers carry 60 to 95 percentage of alcohol which are flammable. So we have to be very careful and we should not handle any fire when we are applying the sanitizers. So make sure you also share this with your parents, so if they are going inside the kitchen or any fireplaces, tell them if they have applied sanitizer, wash it with water before they handle them. Okay children, I hope you will share this with your parents. Today we are going to start a new lesson in physics. Till last class we have completed each one lesson in physics, chemistry and biology. In physics we completed measurement, in chemistry we completed matter around us, and in biology we have completed animal kingdom. Today we are going to start new lesson in physics. The second lesson we have here is motion. Okay children, before going into the lesson, you can see many things around you. What are the things you can find around your house or outside your house? You can see many houses, large trees, small plants or flying birds, and cars moving here and there. Yes or no children? What are they doing actually? They are changing their position. Yes or no children? When anything is changing their position, what do we call it as? We call them as motion. What is this motion? Motion is the change in the position of an object with respect to its surroundings. Everything in this universe is in motion. Sometimes even though the things may not be seen to be moving in on the earth, yes or no children, we don't feel like we are moving, but the earth is rotating and revolving around the sun. Actually it is moving because earth is moving around the sun, but we don't feel that. And also you may see the objects moving in your surroundings, like cars along the road, trains along the track, and aeroplanes in the sky. They are all in motion. They also will be coming along a particular type of motion. And you may also see a fan rotating in the ceiling. This is also another type of motion. When you are playing swing, it moves to and fro. It is another type of motion. So motion is described in terms of the terms of distance, speed, acceleration and time. So in this lesson we are going to study in detail about all this motion in detail, like displacement, velocity, distance, acceleration, speed, everything we are going to see in detail children. Let us move into the class. First we have is rest and motion. How the rest is described or defined in physics is that the object which do not move or change their position is said to be at rest. What is an example? Very simple example. When anything is kept at one place, for example a book kept on the table, or the walls of the room are at rest, we can say, or any object you placed in a corner, it will be at rest unless and until if you don't disturb them, they are at rest. The definition of rest is the object which do not move their position are said to be at rest. Next we have is object which change their position are said to be in motion. Change their position means what? You are having a play toy which will be in one place in the morning and you will throw that one in another place, or otherwise if it is a moving car or a toy car, moving toy car, it will be, if you are having a remote control, it will be in one place. If you control it, it will move from one place to another place, then it is said to be in motion. like cars and buses running on the road, and birds and aeroplanes flying in the air or in motion. Even the plants which do dance on the air, it is also in, the leaves of the plants are also in motion, we can say. This motion is a relative phenomenon. What does this relative phenomenon mean? Object appearing to be in motion to one person can appear to be at rest as viewed by other person. How we can say this? I will give you an example. Listen now, children. For example, the trees on the roadside would appear to move backward for a person who is traveling in a car. For if you travel in a car, the trees are along the roadsides. If you move means the trees also, you feel like it is moving along with you. Yes or no, children? At the same time, it would appear to be at rest for the same other person who is standing on the roadside. So it depends upon the person how the object is actually, whether it is in rest or a motion. Okay, children, it is at rest if you stand and view it, or if it is in motion if you are moving in a car. So this is, we call it as relative phenomenon. We are relating it. It depends upon the person view. Okay, children. So motion is always a relative phenomenon. Next we are going to see the types of motion. So we have 4 types of motion. In physics, the motion is classified as 4. One is linear motion. Linear means we all know, which is in a straight line. Motion along a straight line. What is an example? A bus and cars moving in a straight road, or an parade done by an army officers, we call it as a, they will be moving, they all will march on a very straight line. That is the linear motion. They are moving also, but their movement is in the straight line. That we call it as linear motion. Next we have a circular motion. What is the circular motion? Circular means what? Any object which is moving in a circular path. So circular motion, you can say one good example, giant wheel. It will always rotate in a circular path. That is an example you can give for circular motion. Or the fan rotating in a circular path, you can say it as a circular motion. Next is oscillatory motion, repetitive to and fro motion. To means to, it will move forward, and fro means it will come back. So to and fro, forward and backward motion at regular interval of time. So you will have, if it, see here, it is moving from one point to another point. So in between it is having some interval of time. The same way from another point. So it is in the center, it is moving this way, to and fro. To and fro means with a regular interval of time it will move forward and backward. That we call it as oscillatory motion. Next we have is random motion. Any motion which does not fall in the above categories, which means they don't come under linear motion or circular motion or oscillatory motion. They will follow their own path. Just like that they will move. For example, you can say movement of ants. Are they following any road pathway? Are they following any straight line or circular? No, they will move as if they're like, as their wishes, or no. So that we call it as random motion. Similarly, we saw Brownian movement in chemistry. The particles were in random motion. They don't follow any particular direction. That we call it as random motion. Next we have another 2 type. One is uniform, other one is non-uniform motion. Let us see one by one. Uniform motion. An object is said to be in uniform motion if it covers equal distance in equal intervals of time, howsoever big or small these time intervals may be. It will cover equal distance. For example, 20 kilometers in equal interval of time means 20 kilometers for every 1 hour it will be covering. If it is so, then we call it as uniform motion. Then an object is said to be non-uniform motion if it covers unequal distance in equal interval of time. For example, for first 1 hour it will be covering 20 kilometer, another 1 hour it is covering 10 kilometer, for another 1 hour it is covering only 8 kilometers, means the time interval is same but the distance covered is different, then we call it as non-uniform motion. And few other example you can give is the movement of clock's hand and movement of the pendulum. They are the examples of uniform motion. For non-uniform motion you can say movement of an asteroid and the bouncing of a ball. All these are all the examples of non-uniform motion. For example, for uniform motion you can see the picture. For example, a man is going to drive a car from Chennai to Trichy. The distance between is 19 kilometer. The man is covering a distance of at first 30 kilometer in half an hour, and another 30 kilometer in half an hour, and last 30 kilometer in half an hour. So totally 90 kilometer. For every half an hour he is covering 30 kilometer, which means his speed is very constant. He drove at a constant speed of 60 kilometers for every hour, so that he will be reaching the destination in 1.5 hours. So which means he is following a constant speed for every equal timing. So we call it as uniform motion. Example for non-uniform motion, you can say the same way. A person is going to travel from Chennai to Trichy. Again the distance is 90 kilometer, but if he is going to cover 30 kilometer in 1 hour and another 30 kilometer in half an hour and another 30 kilometer in 0.25 hours, which means his speed is varying of 30 kilometer and 60 kilometer and 120 kilometer. He doesn't maintain a constant speed, which means that it is an non-uniform motion. Next we have is distance and displacement. What is this distance and displacement mean? See here, distance is the actual length of the path travelled by a moving body irrespective of the direction is called as distance travelled by the body. For example, you want to go to school from your house. Okay children, here you have to, the distance is from this point to this point. So from here to here you have to travel, but in between you don't have proper roadway, in between you have some mountains. You have to take this path. You have to take this path. Here the road symbol is given. You have to take this path. So which means the actual length of the path traveled by the moving body, that is you are the moving body, the actual length of the path traveled by you irrespective of the direction. So here we don't consider the direction. You want to reach the school, so you will be covering it in any way without considering the direction. The amount of distance covered alone, if you calculate, then we call it as distance. Is it clear children? It is measured always in SI system. The unit is meter. It is a scalar quantity which will have magnitude only. Magnitude means what? Amount. Here the amount is the distance covered, like 20 kilometers or 30 kilometers you have covered, or 5 kilometers you have covered from your house to school to reach that point, means that alone we call it as distance. Next is displacement. Listen carefully. It is defined as the change in position of a moving body in a particular direction. It is a vector quantity. Here we are calculating both the distance and the direction, that is amount of the distance travelled, magnitude and direction. Here you are going back to home, from school to home. The direction you are going to travel is, for example, say east, and the displacement you have covered, the distance you have covered is 2 kilometers. So I am mentioning here 2 kilometers you are going to travel in east direction, which means I am mentioning the magnitude along with the direction. Then we call it as displacement. Change in position of a moving body in a particular direction. Here very important thing is what? In a particular direction. change in position of a moving body in a particular direction. If you say mention it with the direction, if you mention distance along with the direction, then we call it as displacement. Since this has both magnitude and direction, it is a vector quantity. This is also measured in meter in SI system. Is it clear, children? Are you all clear? The distance between displacement and distance is actual path covered by a moving body. You will not be worried about the direction here. Displacement means distance covered along with the direction of a moving body. We call it as displacement. So in today's class we have discussed about what is meant by motion and what is rest and motion, types of motion. Under types we have seen linear motion, which means moving along a straight line, circular motion, which means moving along a circular path, oscillatory motion means to and fro motion at a regular interval of time, random motion means movement of an object in any category, that is it does not fall under any of the categories which we have seen before, so which we call it as random motion. And uniform motion means equal distance in equal interval of time. Then non-uniform motion means unequal distance in equal interval of time. Then we discussed about distance and displacement. Distance is a scalar quantity, displacement is a vector quantity. Distance will talk about only the magnitude, that is the path traveled by a moving body. We call it as irrespective of the direction. We don't worry about the direction there. Displacement means change in position of a moving body in a particular direction. It is a vector quantity. Both are measured in the SI unit. The unit is meter. Is it clear, children? In the next class we will discuss about speed, velocity and acceleration. Thank you, children.